already know how to graph. We know how to graph and shade. But just so you see one complete example, and so that we get a little review about practicing graphing. So let's say I want to graph part A. So I have y is less than or equal to negative x squared minus 6x plus 2. So the equation is written in a standard form. How do we graph a quadratic in standard form? What's our first step? Yes. Good. We want to find the axis of symmetry and the vertex, and to do that, we're going to calculate what the value of negative b over 2a is. So in this case, b is negative 6, and a is negative 1. So we get 6 over negative 2, or negative 3. This means our axis of symmetry is at x equals negative 3. So there's my axis of symmetry. And that also means that my vertex is going to lie on that axis. So my vertex is negative 3 comma something. Where am I going to get the y coordinate that goes with the vertex? Plug it in. Good. Okay, so I'm just going to take, it doesn't even say less than or equal to, like. So I'm just going to take y equals, and I'm going to plug negative 3 into the quadratic. So I'm going to get negative 9 plus 18 plus 2. So that will be 11. So my vertex point is at negative 3, 11. 9, 10, 11. Which would be 1 unit off of my graph from here. All right, now if I want some other points, what do I need to do? How do I know how wide or whatever to make this parabola? Yeah?
You plug in different numbers for your x.
Sure. Okay. Yeah, that are close to it, not too far from it. 0 is actually not even bad in this case because remember in standard form, every time you plug in 0, you're getting the y-intercept. What is the y-intercept of this parabola? 2. Okay, because 0. So we could do that one if we wanted. You don't have to. You could have plugged in something closer. And then we want to go ahead and draw the parabola that goes through this. But now we want to take into consideration the actual problem that was given to us. Remember that your boundary could be solid or it could be dashed, depending on what the inequality says. Okay? Do we want a solid or a dashed boundary, depending on this inequality? Solid, because it says we can be equal to the boundary line, so we want to include the boundary line or make it solid. So go ahead and draw in your parabola. Yeah, mine's just going to be really ugly because my thing is not lined up, so bear with me. Very, very ugly. Okay. All right. So next thing we want to do is we want to decide where the shading is, since this isn't an equation and it is an inequality. This isn't just about the line part or the curve part of the graph. It is about a whole bunch of points that meet this criteria. So how do you guys like to decide where the shading belongs on this graph? Plug in a point? Okay, so if I plugged in a point, what would probably be a pretty good point to test? 0, 0, if it's not on the boundary, is usually your best bet because you get to plug in 0 for x and 0 for y, which means less work for you. Okay? If we test 0, 0, then I have to be a little bit careful. Oh, I know it crossed this way, so I know 0, 0 is kind of on the inside of my parabola. Okay? And the difference here between linear functions and quadratics is when you did a linear function, when the line went across your graph, it was always like above or below, okay, or kind of to the left or to the right of the line. Here, your two areas are here. One area is all the stuff outside, and one area is all the stuff that's inside the parabola. It's like a different shaped boundary, so two different shaped sections. Okay? So if we plug in 0, 0, we would be comparing 0, just put a new battery in, to this calculation. Basically, we get 0 is less than or equal to 2. Is that true or false? True. That means 0, 0 should be included as part of the solution or should be shaded. 0, 0 is inside of the parabola shape. All the shading should occur inside the parabola shape because that point needs to be shaded. Okay? So the shading would be all in here. And it would continue, the would continue forever, so the shaded area would continue forever also. That's why we can't solve these by just writing something down. We have to actually show someone a picture, because it's all these infinitely many points. What are other ways that you guys could decide which region should be shaded? Does anybody use a different method, or does everybody plug in a point? Any other methods? All right, just throwing it out there that you can do the same way I think we talked about with absolute values or lines before. You can just pick a point on the graph and think about if you were sitting at that point at that y value and you want y values that are less than the y value that you have from the graph, would I move up or down from this point? I want y values less than this point. Would I move up or would I move down? Down. Notice that if I move down from any point, I'm going to end up inside this area. That would also tell me how to shade it. Okay? It's kind of like more intuitive, they call it, but you can do it either way. I'm just throwing it out there for those of you that it fits your needs. Okay? All right. So now let's talk about what we were talking about before. We're not going to solve with our calculator right now. All right. So this is really like part A is exactly like the problem we had in the math moment, right? So it says up there, remember to carefully analyze the situation. It's really easy for us to get some numbers that are important numbers, but it's harder for us to figure out which way the inequality goes. Okay? So like for part A, what are going to be my important values of x, kind of the pivotal points where it could change from positive to negative, those points on the number line? What are those going to be? What are going to be the zeros of the function that's on the left? So you see what's on the left and what's on the right in part A. When is what's on the left going to equal 0? It's already factored for you. Yes. Good. 4 and negative 7. So basically, it's already set up so that everything's equal to 0. So I want to know when this factor will equal 0, which is when x is 4. And I want to know when this factor will equal 0, which is when x is negative 7. So negative 7 and positive 4 are my important kind of pivotal points on my number line. So somewhere down here there's a negative 7. And then somewhere over here there's a positive 4. I know that these are important points, and I'm going to mark them as points on the number line. Should they be open boundary points or closed boundary points? Open. Okay, and why are we making that decision? It doesn't say we can be equal to the boundary points. It doesn't say we can be exactly equal to 0. We can only be less than 0. So we can't actually include these points because these points will be when it's exactly equal to 0. Those aren't solutions to this problem. It doesn't ask when they could be equal to 0. It only asks when the calculation is less than 0. Okay? Now here comes the analysis part. You don't just get to take the numbers negative 4 or negative 7, positive 4, and just make up some inequality. Figure it out by thinking about how the problem behaves. Okay? And there's kind of two ways to do this, the way we talked about during the math moment and also kind of looking at a graph. Remember that this is really like your x-axis right here. Okay? This is some parabola. X minus 4 times x plus 7 is a parabola. Okay? You're trying to figure out when that parabola is less than 0. In other words, for what x values do you get y values that fall below 0? Okay? So way number 1 to do that, like we saw in the math moment, plug numbers in from each section and see what happens. So keep in mind you have two quantities multiplying together. So when you plug in a number that's less than negative 7, so from this first section on the number line, okay? So like negative 10, just pick one, okay? Negative 10 minus 4 is going to be a negative number. Okay? Negative 10 plus 7 is going to be negative. So if every number I plug in that's smaller than negative 7, I'm going to get a negative times a negative, and a negative times a negative turns out to be positive. So in this section, the graph turns out to be positive. Okay? What about between negative 7 and positive 4? Okay, so pick something in there. Say you pick 0. Okay? And again, think it through. You're going to have something times something else, and you're looking at the outcome. Let's say I pick 0. 0 minus 4, negative. 0 plus 7, a negative times a positive, negative. The graph is negative in this section. Okay. Numbers bigger than positive 4. Okay. If I plug a number bigger than positive 4 in but subtract 4, it'll stay positive. If I plug in a positive number and add 7 to it, that's still going to be positive. And a positive times a positive is positive. Now I want to shade on the number line which part of the graph is my solution, and then I'll write my final answer as an inequality. So all this work on the number line is my analysis and my thinking process to decide my solution. Okay? So read the problem carefully. You want x minus 4 times x plus 7 to turn out so that it is less than 0. Okay? Meaning you want the place where the multiplication turned out to be negative, because negative numbers are less than 0, right? So that's this space right here, which means my solution is an and inequality. Okay, it's that inequality where you have values sandwiched, okay, between a maximum and a minimum. So we have negative 7 would be less than x would be less than 4. This would be my solution. Just to throw out how that's related to the graph, if this was my x-axis, and I knew that negative 7 and 4 were my x-intercepts, okay, because that's where the graph would equal 0, think about if I drew a quick sketch of this parabola. I don't know where the vertex is, anything like that, but if I just sketched it, when you look at the left side, is that a concave up parabola or concave down? Up. So think about if you knew it crossed here and here, and you just sketched it, it would go like this. Correct? Notice that between negative 7 and positive 4, the graph is down here below the x-axis, which means what kind of y values do all these points have? Negative. Okay. But over here and over here, the graph is above the x-axis. So if you had really plotted all these points, what kind of y values would all those points have? Positives. So it's not completely separate from the graphing process. It does match, so you can kind of analyze it two different ways. Okay? This chart relates to how the graph behaves. And then at the end, you just have to pick the right part for your solution. Again, we wanted stuff less than 0. Okay? All right, so you guys go ahead and do part B. We would have to set it equal to 0 to do this comparison, because our comparison is all about positives and negatives. Okay, so they're each on one side of 0. We're not comparing to like the number 5 or something like that. So we would want to bring the 5 over first and then continue the process. Sophia? Yes. Mm-hmm. Yeah, so you would say like x is less than negative 7 or x is greater than 4. So the and is when they're connected between the two things, and the or is out to the sides. And then there are other situations, because you know there are parabolas that don't cross at all, right? So we'll talk about some of those special situations after you guys try them, okay? So go ahead and try this one. You can work with your own. All right, factors. Somebody tell me the factored form of the polynomial. CJ.
P minus 5. P minus 5.
All right. So first step, you have to know how to factor.
Oh, no.
All right, somebody tell me kind of the critical points or the x-intercepts of the quadratic. Sophia. Good. So my main points are at 5 and negative 1. This is not my solution. This is my solution to an equation that I solved by factoring. This is not an equation. Dude, I just changed the battery. Very upset about this. Negative 1. Well,
The battery
yeah.
tube is probably like just a touch longer than that.
Okay. So there's my endpoints. Why did I fill them in this time rather than leave them as open circles? Good. Okay. All right, now to decide where to shade. So those of you that did our analysis, when you plugged in numbers less than negative 1, did this multiplication result turn out to be positive or negative? Positive, because it was negative and negative, which turned out to be positive. So positive here. What about between -1 and 5? How did the result turn out? Negative. And then beyond 5? Yeah, so you see a pattern. That's because it's a concave up parabola and it passes through. Remember, it relates to the graph, right? Positive, negative, positive. Okay? So that's what's happening there. But there are graphs that don't look exactly like that. But if you know enough information about the graph or about how to do the sign analysis, you can figure either one out. So what is my final solution to this problem? How do I write this? Yeah?
-1 is less than or equal to p, which is less than or equal to 5.
Good. Okay. Again, because she chose this area here, because we were looking for when it turned out to be less than or equal to 0. Yes? No. Well,
The whole quiz is just this.
all right. So what I want you guys to do is I'm going to have you do a few on your own. Okay. Some of them turn out to work a little bit special, but we kind of get the idea of what's happening, right? So there's a few more. Those of you that have the note guide have them all listed, and then those of you that don't, you're only seeing 2, but I'll write the other 2 up here on the board so that you can see them. So right now I want you to just take the time and work on these. Oh, are we going to run out of time? We are. That's no fun.
It's so much fun.
All right, let's go to, then let me just help. Let me just do this. Shush. Okay, so if I took, so if I rewrote, I'm doing the try these from part A for a specific reason. Okay. What happens when you factor d squared plus 8d plus 16? You should recognize it. It's a perfect square, yeah. So we get d plus 4 squared, which means how many little critical points or zeros are we going to see on our x-axis? Only one. At which number? -4. So 0, somewhere is -4. Should I fill it in or keep it open? Fill it in. Okay, when I plug in numbers smaller than -4, I add them to 4 and then square it. Am I going to get a positive or a negative result? Give you a hint. The last thing you're doing is squaring the number. Positive. Okay. When I plug in a number over here, add it with 4, and then square it, I'm going to get a positive. All right, so it's a little bit different, right, because of the perfect square idea. So when is this perfect square greater than or equal to 0? Is it greater than or equal to 0 in this first section? Yes. Are we allowed to include the point? Yes. Is it greater than or equal to here? Yes. So it's everywhere, which is all real numbers. So think for a minute if we had done this same problem, just to give you a quick glimpse. Let's say that we had done the problem but said when is it less than 0? The analysis would be the same because the problem is the same, except for because I didn't include the equal to, this would be open. So if I had a positive section, my point, another positive section, for the same reason we did the analysis before. When is this less than 0? Never. What would we say? No solution. How would that change if I allowed it in this case to be equal to 0? I would have one solution, which would be exactly at -4, because the difference would be that would be able to be filled in. And then I would say x equals -4. Okay? What if in this problem over here, I had taken off the equal to part, meaning this was an open circle? When would this perfect square be greater than 0? Is it greater than 0 in the first section? Can we include -4? No. Is it greater than 0 in the next section? So it would be all real numbers except -4. Okay? So same process, but do the analysis. Do you guys understand how important the analysis is? So when I end this lesson, I always put up this slide. Okay? This is how you're going to feel if you don't sketch the graph or look at the number line. And this is how you're going to feel if you do. Okay? Sketch the graph.